All right, we're going to talk about adding and subtracting radicals. So, in order to do this, you just basically need to remember the rule to combine like terms and how to simplify, obviously, radicals. So, basically, you're going to make sure, let me write some steps here for you, just because I like to have them here. Step one, you're going to simplify each root. All right, and then you're going to add or subtract the coefficients of the ones with like terms. And that is really all. So you're going to simplify each one, and then you're going to add or subtract the ones with coefficients or like terms. So for example, we have 3 root 27 minus 2 root 12. Well, step one is to simplify each one. So you can do this in your head. You can do this the way we talked about in class, but I'm going to say 27 is 9 times 3. I know that 9 is a perfect square, so it's this one is really this 3 on the outside times the square root of 9, which is 3, and we have a leftover root 3. So completely simplified, we have 9 root 3 minus. Think about what perfect square you can divide 12 by. Hopefully you got 4. So 4 and 3. So we have our 2 that was already outside. The square root of 4 is 2. Oops. Sorry, I'm putting this in the wrong place, but it's fine. And then we have our leftover root 3. So we really have 9 root 3 minus 4 root 3. In this case, we can subtract them because they have like terms. So the answer is 5 root 3. And that is really the gist. That's the entire process. So let's do a couple more. Let's try this one. Oh, this one has some multiplication in it too, so it's good. All right, so we need to find or simplify each radical. So I'm going to simplify this one. What perfect cube can you divide negative 40 by? If you can't think of it, you would go through this process. All right, and this one can really be negative 1 and 2. So you have all of these. This is just showing you the long process. And that means what we really have is 3 and all these factors. Okay, let's do the same for this one. 135, we can divide by 5 for sure, is 27. Now, at this point, I'd be like, score, look, I got a perfect cube. And that's where I would stop. But I'm going to bring this one down for anybody that kind of needs to see the whole process. And write the rest of our problem. Now we have 5, 3, 3, 3, and oops, I forgot to write 8 to the 7, 8 to the 4. All right, so as far as our numbers go, we have a group of 3 2s, so that's going to go on the outside. We have the negative, which can come out also. So I'm just going to stick that out there with it. And what else do we have? So this a to the 7 can be written as a to the 6, the cube root of that, times the cube root of a. That's 7 of them. And divide 6 divided by 3, a squared on the outside. So what we have left is 5a, and that's it. We have the 5 and this a because we did this one. We're going to do the same thing over here. We have 2a squared times a group of 3's. That's the square root of, or cube root of 27. A to the 4th is a cubed times a. So we have an a on the outside. And on the inside, we have 5 and that a. Now we need to simplify right here. So we have negative 2a squared times the cube root of 5a plus 6a cubed times the cube root of 5a. Now in this case, we cannot add these together because these are not like. The radical part is like terms, but this part is not a like term. So this is the end. That's the answer. All right, I made that one look very complicated. Let's do one more. So for this one, you should try to pause the video and try it yourself and then come back and check. I know it might be a little confusing because I was trying to show you 2 different methods, but they both work. So I just want to make sure you have a lot of options. All right, so pause the video and come back and check your answer. All right, welcome back. So we're going to have to simplify the radicals. We're going to check each one. This one, I can see that it has 49 in it, and 49 is a perfect square, so that's awesome. X to the 4th can be written as x to the 4th. It's perfect. It has an even radical, so that one's great. We have the square root of x to the 4th. And y squared, the same. An even radical, an even index, so we're okay. For the other one, there is nothing to simplify. It's already simplified. So now let's go through and simplify as we go. The square root of 49 we can do. That's 7. The square root of 2 we can't do, so that goes here. X to the square root of x to the 4th, we divide. 4 divided by 2 is x squared. We have 2 groups of 2 x's. Y squared becomes just y because we divide. 2 divided by 1. We have 1 group of 2. Minus 3x squared y root 2 because that was already simplified. Now you can see we have exactly the same parts. This entire part has to match. And then you just work with that number in the front. 7 minus 3 is 4, and everything else stays the same, just like combining like terms. All right, that is adding and subtracting radicals.